The Earth is doomed. It's only a matter of time. Although it's difficult to predict how long our planet will actually exist, its ultimate fate is predetermined, because our home planet will die along with our sun in about 5 billion years. All life on Earth will be extinguished long before then. If humanity wants to survive, it will have to leave its home planet while there's still time.
How will humanity evolve on Earth in the future? I'm not talking about the next 50 to 100 years, but over thousands and thousands of years. Could we leave the Earth one day? Might we be forced to leave? The answer is clear, absolutely, because we know that the sun is slowly but steadily getting hotter. In 800 to 900 million years, temperatures will rise to a point where higher forms of life can no longer exist on Earth. So if humanity wants to survive, it will have to leave Earth and colonize other planets, perhaps even the entire Milky Way.
In November 2022, the world's population surpassed the 8 billion mark, an impressive figure, especially when you consider that there were only about 300 million people living on Earth just 1,000 years ago. Experts project that the population could increase by another 3 billion by 2080. How many people our planet can sustain in the long run remains uncertain and is often the subject of bleak predictions. However, scientists believe that a global population of 10 to 12 billion people will pose no problem for the planet.
Leaving the Earth because it might become too small for so many people, for 10 billion people, that sounds tempting, but I think it's completely unrealistic. If we choose to leave the Earth, we'll want to do it because it's uninhabitable, because we will have made it uninhabitable. But leaving the Earth would be incredibly expensive. So ultimately, it would make more sense to use that money to keep the Earth habitable. When I weigh the costs and benefits, I find it highly unlikely that we could ever relocate millions of people to other parts of the universe. The costs alone would likely be many times higher than what it would take to keep Earth habitable.
As the population continues to grow, food production will need to keep up in the coming decades. Current projections suggest that in 30 to 50 years, we will need to produce twice as much food as we did at the start of the 21st century. At the same time, energy demand is rising, while our resources remain limited.
We should learn to be responsible stewards of our planet, to take care of it and nurture it like a garden. And once we learn to do that well, then we can consider venturing elsewhere to build something new. But simply depleting our planet's resources, destroying our home, and then being forced to leave is, in my opinion, a rather embarrassing solution.
In addition, people are living longer than ever before. Over just 5 generations, life expectancy in industrialized countries has roughly doubled, from around 35 years to over 80. Today, prosperity, medical advancements, and improved working conditions allow more people to reach old age. In fact, the rise in life expectancy over the past century is unprecedented. It surpasses the total evolutionary progress from apes to Homo sapiens. The decline in human mortality during this period has no parallel in biological history.
The external pressures from the environment that once drove evolution on Earth are no longer as strong. But that doesn't mean that evolution has stopped. Some people, for example, are resistant to certain diseases, while others are not. Evolution is still happening, but where it will take us is hard to predict.
Individuals are living longer than ever. But what about the life expectancy of humanity as a whole? Predictions of the apocalypse and humanity's downfall have existed for centuries. Yet, neither global wars, epidemics, nor climate change will bring about the end of Homo sapiens.
If you look at how humanity is developing, we can't quite seem to get the knack of living together. We're plundering the earth. We're making life difficult for each other. And at the moment, I don't see any end to it. I'm also not so sure that humanity really is the ultimate zenith of terrestrial evolution. Maybe it's just an intermediate stage and humans will eventually fulfill their purpose, whatever that may be. And then something new will develop, a new kind of life that goes beyond what humans can achieve.
Individual natural disasters, such as earthquakes, floods, or pandemics, do not pose an existential threat to humanity. While they may claim countless lives and cause global economic damage, they are not capable of wiping out the human species. For a true existential threat, multiple catastrophic events would need to occur simultaneously, such as a global nuclear war combined with a comet impact, triggering a nuclear winter. Humans are resilient. Those born in 1900 lived through the First World War, the Great Depression, the Spanish flu, and the Second World War, all within just a few decades. Each of these crises was historic in scale, but none of them threatened the survival of humankind.
Every step of the way, the development of life has been a miracle of adaptation. But it took a long time. The first single-celled organisms, known as prokaryotes, did not appear until 1 billion years after the Earth's formation. And it took another 3 billion years for the first multicellular organisms to emerge. Then something extraordinary happened. 550 million years ago, there was an explosion of life, known as the Cambrian explosion. From that point on, evolution accelerated. Animals grew larger and larger, culminating in the age of the dinosaurs, which ended abruptly 65 million years ago. This extinction event opened the door for humankind to emerge 2.6 million years ago. Early humans were the first to use language and tools, and then, about 200,000 years ago, modern humans, Homo sapiens, appeared in Africa. Only then did our species begin to spread across the globe.
Like all planets, the Earth formed from an interstellar nebula, a vast cloud of gas and dust left behind after a supernova explosion. Gravitational forces caused this primordial cloud to collapse and condense. From the rotating disk that emerged, the Sun took shape around 4.5 billion years ago, while the remaining material gave rise to the planets, including the young Earth. A glowing sphere of molten rock surrounded by a toxic atmosphere created by volcanic eruptions. It consisted mainly of water vapor and carbon dioxide, along with traces of methane, ammonia, nitrogen, and carbon monoxide. Over time, the Earth's crust eventually solidified as it cooled, and condensing water vapor formed the first oceans. How life could have emerged from this lifeless matter remains one of the greatest mysteries to this day.
The big question about the first cell is whether life is just a biochemical process that emerges naturally whenever the right conditions exist, or if there's something more, something beyond just physics. I don't think this second aspect is necessarily a bad thing. In fact, it makes the mystery of life much more exciting than if it were just pure physics as we know it.
Our Earth has been shaped by the very life it has produced. Today, scientists believe that the first life emerged around 3.5 to 4 billion years ago, presumably in small enclosed environments where biomolecules could interact and react with one another. However, we still lack a clear picture of how land and water were distributed at the time, and we don't know precisely what temperatures prevailed on young Earth. What we do know is that liquid water played a decisive role. Early organisms, such as bacteria, altered the chemical composition of the soil, water, and atmosphere through their metabolic processes. This laid the foundation for a complex habitat in which all organisms are interconnected, the biosphere.
When talking about evolution, it's important to understand that it has no ultimate goal. Over millions of years, natural selection has shaped life on Earth. This selection pressure ensures that organisms adapt to the prevailing conditions, particularly in terms of food and reproduction, allowing species to sustain themselves. However, humans have found ways to bypass this to some extent. For example, today people with a greater cold tolerance no longer have an advantage over people who are more sensitive to it because we have inventions like heating. In the past, this would have been different. Back then, only the people who could tolerate the cold might have survived.
The Cenozoic era began around 65 million years ago and continues to this day. It marked the end of the Mesozoic era, and with it the age of the largest land vertebrates, the dinosaurs, which lasted over 200 million years. By the start of this new era, the continents were already close to their present-day positions, and the global climate underwent a dramatic shift. The warm and ice-free Earth turned into a cold planet with polar ice caps. Nearly 12 million years ago, our early ancestors shared the Earth with the first apes. Around 7 million years ago, the evolution of prehistoric humans began as they adapted to shifting environmental conditions. The result is Homo sapiens, modern humans who dominate the planet today.
Is it possible to predict the future of our planet, and with it, the fate of humanity? No, not in detail, but in broad terms, yes, we can. We know that Earth's axis is tilted and shifts over millennia, causing an ice age roughly every 100,000 years. The next one is expected in about 50,000 years. We also know that continental drift will increase in the future, gradually bringing today's continents back together. In about 250 million years, they will merge into a single supercontinent. And we've already named it Pangea Ultima. This ongoing continental drift will also increase volcanic activity, releasing more carbon dioxide into the atmosphere. As a result, global temperatures will rise dramatically. Experts predict that at some point, the average daily temperature could reach 48 degrees Celsius. When that happens, Earth will become a desert planet, one where higher life forms can no longer survive.
In 250 million years, human life may still exist on Earth. However, life as we know it today will no longer be possible. Extreme volcanic activity will lead to a massive increase in carbon dioxide levels, while solar radiation is expected to rise by 2.5%. Earth will become unbearably hot, an almost uninhabitable desert planet.
As the sun continues to get hotter, and it will, that's certain, Earth's surface will eventually become uninhabitable. It will simply be too hot, and it's highly likely that water will evaporate, stripping us of the very foundation of life. One possible solution would be to move underground, and we'd still need to find enough water. I almost said bring it with us because water is the essential substance for biological life. It's highly likely that humanity will find a way to survive, but not in the numbers we see today. Instead, I believe that only very, very small populations will remain, living below the surface and carefully managing and recirculating guarded water supplies.
Researchers believe that Earth is currently in a supercontinental cycle. The continents are gradually drifting back together and will eventually merge into a single landmass. This new supercontinent, called Pangea Proxima, is expected to form along the equator in around 250 million years. Model calculations predict that large parts of this huge landmass will experience constant temperatures above 40 degrees Celsius, making it utterly inhospitable for human life. Adding to this, the ongoing increase in solar radiation will drive temperatures even higher.
There is already a concept of deploying mirrors in space to reflect some of the sunlight. This would allow us to regulate how much solar radiation reaches Earth and how much energy we want to absorb or deflect.
Earth as we know it today will exist only in myth and legend, like the biblical Garden of Eden, a once fertile paradise that future generations, having lived in relentless heat and desert landscapes, will no longer be able to imagine. The story of our time, the history of early humanity, will one day be nothing more than a distant fairy tale.
Ants, I suppose they'll survive forever. They won't care about any of this. And maybe over time they'll even develop intelligence. Perhaps an anthill will function as a single thinking organism, one that contemplates itself, maybe even the universe. By then, humans will no longer matter at all.
The human species, as we know it, may one day be replaced by a completely new form of life on Earth.
So, in 250 million years, it's death due to heat exposure. That much seems certain. But long before that, in 50,000 years, we'll face another ice age. That doesn't sound great either. The real question is, will we even make it that far? We know that at least 1,000 asteroids, each over a kilometer wide, are drifting through space, any one of them capable of wiping out all higher life on Earth. The last time this happened was 65 million years ago when the dinosaurs went extinct. When will the next one hit? We don't know, but we do know that one day it will.
Dinosaurs ruled the Earth for around 200 million years. During the Mesozoic era, also known as the Age of the Reptiles, they dominated the planet alongside marine reptiles and pterosaurs. Then, around 65 million years ago, they almost completely disappeared. The exact causes remain uncertain, but scientists believe a massive meteorite impact near the Yucatan Peninsula in Mexico and the resulting climate changes played a key role. The collision likely triggered a global firestorm, creating a huge cloud of dust that darkened the sky. With less solar radiation reaching the Earth's biosphere, temperatures dropped dramatically, leading to a phenomenon known as nuclear winter. Only a few life forms survived this catastrophe, including crocodiles and turtles.
The next asteroid that is at least 1 kilometer wide is already overdue. When it eventually crashes into Earth, it'll trigger the ultimate environmental disaster, a global blackout followed by a cascade of catastrophic events. We won't be able to fly for maybe 50 years due to extreme atmospheric pollution. In fact, everything will change. Fortunately, we're now learning how to deflect asteroids.
The winners of the climate catastrophe 65 million years ago were the small mammals that had evolved alongside the giant reptiles. They laid the groundwork for the long evolutionary path that would lead to Homo sapiens, the thinking man, around 300,000 years ago. A major milestone in human evolution was Australopithecus, a pre-human species that lived in Africa between 4 and 1 million years ago. Scientists consider it the direct ancestor of the Homo genus. The earliest of these species, Homo habilis, was the first to develop an upright posture and a bipedal gait.
The most important factor seems to be replication, the ability to pass information on to the next generation without interruption. This means avoiding enough errors that could otherwise cause the next generation to die out. This process is the key to survival.
The first massive extinction of life on Earth occurred around 250 million years ago. Known as the Great Extinction, this event marked the boundary between the Permian and Triassic periods. In other words, the transition from the Paleozoic to the Mesozoic era. According to current estimates, it affected around 2/3 of land-dwelling species. Marine life suffered even more severely. Barely 5% survived. The planet's biodiversity was drastically reduced. Scientists still debate about the cause of the mysterious catastrophe. One leading theory points to extreme volcanism in the northern hemisphere. Others suspect a meteorite impact that may have triggered a new ice age. Some researchers believe they have identified the remnants of an asteroid impact around 250 million years ago in a conspicuous geological structure beneath Antarctica's ice sheet. The shock wave from this estimated 50-kilometer wide rock could have triggered volcanic eruptions on the opposite side of the globe. But there is still no definitive evidence to support this theory.
History moves from one disaster to the next. Yet so far, every catastrophe has led to something new. We have learned and moved forward. We evolve, we adapt, and perhaps this makes life even more worth living. The real question is, are we learning quickly enough to keep progressing, or will we fall behind? Have we reached the peak of our development, and it's downhill from here? Or can we take the next step?
One thing seems certain. A cosmic catastrophe such as the impact of a so-called planet killer would mean the end of humanity. An object with a diameter of 10 kilometers or more would unleash energy equivalent to several million Hiroshima bombs. Such an impact would not only wipe out Homo sapiens, but also push Earth into a new geological era. Humans could only save themselves by detecting the asteroid early enough and successfully deflecting it, or by escaping to other celestial bodies.
If humanity had to leave Earth one day, where would we go? Venus? No, far too hot. Mars? There's no surface water. So we'd have to look beyond our solar system and head for the nearest star, Proxima Centauri. It has a planet called Proxima Centauri b. The only problem is that its star is a red dwarf, meaning it constantly emits X-ray flares, powerful bursts of radiation. And that's far from ideal for life. To make things worse, the planet is tidally locked, with one side always facing the star. So that side is very hot, while the opposite side remains in perpetual icy darkness. Still, assuming we decide to go, how long would it take to get there with today's technology, using every trick we know, like gravitational swing-bys? It would take 100,000 years. And even with future advancements like fusion or antimatter propulsion, the journey would still take several thousand years.
With today's technology, a journey to the closest exoplanet, Proxima Centauri b, would take over 6,000 years. Humanity would have to leave Earth aboard so-called generation ships. Only the distant descendants of the original crew would reach their destination. Researchers at the University of Strasbourg analyzed the survival probability of missions with various crew sizes and simulated the feasibility of such a voyage. Their findings suggest that at least 98 people, that is, 49 couples capable of reproducing, would be needed to set off for this distant world. To ensure survival, the crew would follow strict rules, including a predetermined number of births per year. The model also factored in challenges such as infertility, inbreeding, sudden deaths, and catastrophic accidents.
Calculations like this should always be taken with a grain of salt as they involve a great deal of speculation. We have to consider the timescale. If we look back 5,000 years in human history, the first advanced civilizations on Earth had only just emerged. While 5,000 years sounds short in cosmic terms, it's a vast expanse of time for us humans. In other words, predicting what a human population might do in 5,000 years is virtually impossible. And the idea that 49 couples could sustain a population for 5,000 years and manage not to kill each other or quarrel, that contradicts everything we know from our own life experience. In this sense, I find it highly implausible that such a mission could ever truly succeed.
Around 250 human generations would live and die on the emigrant spaceship before reaching its destination. The vast majority of those on board would be born and pass away without ever seeing Earth or another planet. And even the final generation, the one that actually arrives, might have long forgotten why their ancestors set off in the first place. By then, the spaceship would be their natural habitat.
To ensure survival, you need to create a self-sustaining ecosystem. You need air to breathe, you need food. Energy must also be supplied, something we can theoretically manage for long periods of time, for example, with a nuclear reactor. At least that much seems feasible. We could develop a plan A for this. So far, no one has succeeded in building a fully self-sufficient, closed system. But with enough funding and willpower, you could develop something like that.
A journey like this would require a spaceship capable of maintaining a constant speed of around 700,000 kilometers per hour, a realistic figure. The fastest object built by humans so far is the Parker Solar Probe, a spacecraft designed to study the sun. It travels through space at around 650,000 kilometers per hour, though it achieves this by using the sun's gravity to accelerate.
If no cosmic catastrophe gets in the way, humanity could one day colonize the entire Milky Way. But what would that actually look like? First, we would need to identify the right exoplanet. Using space telescopes, we would take a closer look at the atmospheres of distant worlds. And if we detect methane or ozone somewhere, we'd know there's likely plant life, and we would travel there. Then, after about 10,000 years of regeneration, humanity would move on to the next exoplanet. By planet hopping across the galaxy, humanity could theoretically colonize the entire Milky Way within less than 10 million years. If humanity wants to survive long term, this may be exactly what it needs to do.
For humanity to spread across the galaxy, our civilization would have to undergo a complete transformation. In addition to technology, what's needed most is the unwavering will to let go of Earth. It would be a final farewell to our home planet for countless generations that would live entirely aboard spaceships. These settler ships would travel through the lonely void of space for thousands and thousands of years, the only way for humanity to cross the immense distances between stars. Because the human lifespan is far too short for the scale of the cosmos.
Humans aren't built for space travel. Our lifespans are simply too short. Let's take 100 years as a rough benchmark. With conventional propulsion, 100 years won't get you very far in the universe. Human beings are not suited to interstellar travel. Even if we had a propulsion system 100 times faster than what we have today, it would take around 1,000 years to reach the nearest star.
Therefore, it is by no means certain that humanity will ever spread across the galaxy. Still, scientists are exploring such scenarios. In 2019, a research team from the European Space Agency ESA took part in a NASA-organized competition to determine how humanity can colonize the entire Milky Way as efficiently as possible. What's still missing, however, is the technology for an efficient propulsion system.
In 100 or 200 years, or maybe even next week, I'm convinced we'll find a loophole that will allow us to make this happen. As Arthur C. Clarke famously said, any sufficiently advanced technology is indistinguishable from magic. Take the smartphone, for example. 100 years ago, that would have been pure magic, absolutely unimaginable. Today, sure, you have to invent it. Semiconductor technology and so on, these things didn't exist back then. And in the same way, a century or two from now, there will be so many new toys that we can't even dream of today. And whether you call it magic or unimaginable, they will make the impossible possible.
The ESA team's solution earned third place. Their concept? To conquer the galaxy using spaceships that travel for thousands of years. Multiple interstellar arcs would launch from Earth, each heading in a different direction. Once a neighboring star system was reached and colonized, some of the settlers would immediately set off for the next star. This process would continue again and again. Over time, and with increasing momentum, humanity would expand. Eventually, humans would reach every potentially habitable planet in our galaxy. But the process would take many hundreds of thousands of years.
When you consider that it would take thousands of generations for humanity to reach and settle other planets, it seems rather unlikely, and also, frankly, a little dull to travel across the universe. You would need to fly at the speed of light, something that's far beyond our current capabilities and way of life. Humanity would have to change biologically as well. That's why, for the time being, our best chance for survival is here on Earth. And we can send robots into the galaxy instead.
Today, the basic requirements for any scenario to colonize our galaxy are far beyond our reach. Humankind would need advanced propulsion technology and vast amounts of energy. As early as 1918, rocket pioneer Robert H. Goddard outlined the idea of an interstellar arc. In his proposal for leaving Earth, he suggested using small moons or asteroids as spacecraft. The crew, he imagined, would travel in deep sleep, suspended animation lasting for centuries. Goddard titled his vision, "The Ultimate Migration," and noted that it should only be read by optimists. "The only obstacle to human development or progress is ignorance," he wrote, "and this is not insurmountable."
When you study something like this, you're really asking, what do the laws of physics allow? Or, put another way, if we accept the natural laws as they currently stand, what would a journey like that have to look like? What kind of spaceships would we need to build? What kind of supply systems would be required? Because one central question in designing any spaceship is, where does the energy for the journey come from? And just as important, how do we take that energy with us?
Rocketry pioneer Robert Goddard, who received little recognition during his lifetime, was not the only one thinking about interstellar travel. In 1928, Konstantin Tsiolkovsky, who is considered the father of spaceflight theory, described a space colony equipped with engines traveling through space for thousands of years. In his essay, The Future of Earth and Mankind, he imagined the crew of this futuristic Noah's Ark changing so profoundly over time, physically and socially, that the memory of Earth as their home planet would eventually fade away. The foundation of all these ideas is the same: spaceships capable of housing an entire human community for many generations while ensuring their survival. Such an ark would have to be completely self-sufficient, a closed ecosystem, functioning without the possibility to pick up supplies, fuel, or materials for repairs along the way. To build such a vessel, humanity would have to say goodbye to Earth and even to the solar system. We would need to re-see ourselves in a new light as a planetary species.
There was once a project called Mars One. They were looking for people who were willing to volunteer for a mission to Mars, but only for the outward journey. They were told, "We won't be able to bring you back. You have to form a colony on Mars and stay there." And there was a call for applications, and you could apply. Thousands of people applied for this project, which would definitely have taken them to Mars, but not back. This project was not supported by the international space organizations for ethical reasons, because all manned space projects have always been designed as round-trip missions. But you could see that there are obviously a lot of people who are willing to make themselves available for this voyage of discovery.
It's unlikely that humanity will begin thinking and acting as one anytime soon. On that front, we see little to no progress. The situation is quite different, however, when it comes to developing new technologies. One of the greatest challenges facing deep space travel is propulsion. Conventional rockets, as we know them today, are not suitable. The sheer amount of fuel required excludes them from serious consideration for interstellar missions.
Rocket technology has been around for a while. The fuel has a chemical reaction, and you produce a hot gas. That gas comes out the other side, and that's why you move. The next iteration works better because you're not using chemical energy, but electrical energy instead. This allows you to work a little differently. You can also use other fuels. The lighter the fuel, the more efficiently it actually works. The higher the speed that comes out the back, the higher the speed you can ultimately achieve with something like this.
Manned missions through the solar system will pose an enormous challenge. They will not become possible or reasonable without entirely new technologies. Electric propulsion systems, such as ion thrusters, offer the efficiency needed for long-distance spaceflight, but they produce far too little thrust. The required speeds will likely only be achievable through atomic power and the use of nuclear propulsion technologies.
This sounds completely crazy, but you would have to detonate a nuclear bomb behind your spaceship. And that would give you the greatest thrust and the greatest acceleration you can imagine. And if you take fusion bombs, that's basically the most energetic thing we have. If you actually use that as a fuel, by the way, it's something called Project Orion, which was conceived in the 1950s and 1960s and even underwent limited testing. It's technologically possible. If you take it to the extreme, with the best we have, you might reach a speed roughly equivalent to solar wind. And that would take you to the nearest star in about 1,000 years. But that's the end of the road.
No known technology would allow us to travel even to the nearest solar system, at least not within a time frame compatible with human life expectancy. Human life is simply too short, and the distances are unimaginably vast. Even future technologies like nuclear fusion drives would only achieve a fraction of the speed of light, at best around 1%. To reach the closest star system, such spaceships would still need to travel for many hundreds of years. And even then, a spaceship accelerated to such speeds would have to start decelerating long before reaching its destination. That's why in science fiction, And even in some theoretical physics concepts, space itself is warped or bent to shorten the journey, traveling faster than light using a warp drive.
They bend space positively and they bend space negatively and thereby create a kind of escalator in space-time to move their spaceship. You can calculate this mathematically, but we don't have a device with which we can simply bend space positively or negatively. At the moment, they're just mathematical models. And as an engineer, I don't know what to do with them. They don't tell me how to go about building anything.
Alongside these considerations, we must also ask, will it be the human organism as we know it today that will conquer the galaxy? Or will humanity evolve into something completely different? A species of autonomous sentient machines, or a hybrid of man and machine? Maybe it won't be humans who venture deep into the cosmos, but rather the artificial intelligences we create.
Will humanity evolve? Of course it will. Continuous adaptation to our environment is at the heart of biological evolution. And we already have a sense of where this journey is heading, because we can see it today. Less physical labor, more cognitive work. And even that is increasingly being taken over by artificial intelligence. But AI is silicon-based. We, on the other hand, are carbon-based. Could we imagine that there's silicon-based life out there? The answer is no. Silicon-based life cannot emerge on its own. But once in the world, we can imagine silicon-based life, even machine-based life, human-like in form and built to self-replicate, like the theoretical von Neumann machines.
Long-term stays on the International Space Station have shown that the human body is not well suited for permanent life beyond Earth. A truly interplanetary species, one that ventures beyond our solar system, may look very different from the humans we know today.
In evolution, it's always the case that the main task of any given species is survival. Now that humanity has managed to develop technology, this is no longer our primary goal, because we can use technology, in other words, help from outside, to ensure our survival even in places where we would not normally be able to survive. That means humanity will intervene in evolution to prolong its life, to make its life more comfortable. These are all dangerous things, and you have to think carefully about whether you want to do them or not. These will be social questions that humanity will have to answer. It won't be a question of whether we can do it. It will be possible. But the question is, will we want to?
Carbon-based humans may ultimately turn out to be a dead end in the story of evolution. The human organism is fragile, highly sensitive to heat, and consumes a lot of energy. What's more, it does not live very long. From an evolutionary perspective, shifting to a silicon-based foundation might be the right path. Incorporating silicon in the building blocks of life may well be possible.
If we don't evolve from carbon-based life, then we'll die out for various reasons. So we have to try to make ourselves more robust. And making ourselves more robust can be achieved by trying to create silicon-based life. The invention of the transistor in 1947 was the first step. Then we moved on to computer development. And so we're slowly but surely freeing ourselves, so to speak, from this carbon-based life. And artificial intelligence is, of course, the next logical step. That's why it's so exciting to see what we're currently experiencing. The key question will ultimately decide this issue. Will artificial intelligence be able to develop a consciousness? In other words, will the artificial intelligence know that it's there and then fight to stay there? And if it does that, if it develops consciousness and thinks about it, I want to survive, essentially, I want to stay there, then we will have made it. Then we've basically transformed human life, biological life, into silicon-based life. And that's much more robust than our carbon-based life, much more able to withstand environmental effects.
Medical science will continue to advance, but the human body will never exceed a lifespan of about 150 years. Artificial intelligence, on the other hand, could save humanity. It already plays a significant role in our lives, and it's entirely conceivable that humans and AI will increasingly merge into a symbiotic unit.
I think humans will continue to evolve, and perhaps a new form of life will then develop out of humanity. It's also possible that humans will combine with artificial intelligence and other robots, that humans will become a kind of hybrid being, and that this could then be the new kind of intelligent life.
Humans and computers, working together as an inseparable unit, could become far more effective than either alone, to the point where their evolutionary futures become irrevocably linked, a human-machine hybrid that ensures continuity.
I think artificial intelligence really is the next revolution that we're currently experiencing. And of course it has risks, but it has many more opportunities. And I believe that the opportunities are greater than the risks. And when I look at what we've seen in the field of artificial intelligence in the last 2 years alone, I think we're in for a surprise or two. With this in mind, we should always remain optimistic. And I believe that there's no better opportunity to explore the universe than this.
Artificial intelligence may represent the next decisive step in human evolution, or at least an artificial extension of it. Even if the idea sounds dystopian, perhaps it's only the next logical stage. Cyber-humans, no longer based on carbon, who leave Earth behind before the sun brings an end to life on our planet.
Looking back, what does the end of humanity on Earth look like? In probably 250 million years, or in 800 or 900 million years at the latest, the Earth will be so hot that it will be a desert planet. And then it's game over. What's more, in 5 billion years, the sun will have expanded so much as a red giant that it will swallow up the Earth. The Earth will no longer exist. If humanity wants to survive, it will have to leave Earth. First, we'll have to look for a habitable planet, and then travel there. In the long term, we'll colonize the entire galaxy, our Milky Way, by planet hopping. As the Russian space scientist Tsiolkovsky said, Earth is the cradle of humanity, but we can't spend our whole lives in the cradle.
Leaving our home planet and colonizing the galaxy, an awe-inspiring idea and impossible with today's technologies. Still, humanity may have no future unless we eventually make it a reality. Around 65,000 years ago, modern man set out from Africa and spread across the Earth. Today, we have colonized the entire planet and have already taken our first small steps into space. So perhaps it's only a matter of time before we extend our reach through the solar system and eventually across the Milky Way.